Hi everyone. Today we are going to talk about recursion. Using recursion, we are going to solve our first problem, Fibonacci numbers. Recursion is just a function calling itself. Fibonacci number, commonly denoted by f of n, forms a sequence called a Fibonacci sequence, such that each number is sum of the two preceding numbers starting from 0 and 1. That means, let's understand Fibonacci sequence. So the first item of the sequence is 0, the second item is 1, and we can calculate any new item, the next item, by adding the previous two numbers. So what would be the third Fibonacci number? 0 plus 1. The, the next one is going to be adding previous two, adding previous two, just keep on adding previous two, and we'll keep on getting the new number. So we call this Fibonacci with at an index of 0. This one is Fibonacci at 1, Fibonacci at index of 2, up to so on. So the question is, we will be given the index of Fibonacci and we have to output the number, Fibonacci number kept at that place. Okay, so if n is equal to 2, that means Fibonacci of 2, we have to output 1. Sure. So just by the look of it, we can see a little bit of repetition is there. Fibonacci of n is Fibonacci of n minus 1 plus Fibonacci of n minus 2. So how we can solve it? There are many different ways. Actually, we can solve it just by linear iteration, but just to understand recursion, let's solve it using recursion. So we are saying we have a function with an input of n that represents index of Fibonacci, and output is an integer representing the number kept at that index of Fibonacci sequence. So to get the output, we just have to grab the previous Fibonacci number and the one before that, and that is all. So Fibonacci of n is equal to Fibonacci of n minus 1 plus n minus 2. As simple as it can get. We are doing recursion because we are calling the same function within the function, right? Now the only problem is there is no terminating condition. Terminating condition is very important for recursion, because if you just look at this example, if we do not add the terminating condition, and let's say we started with f of 3, we'll get to f of 3 and the function says return f of n minus 1 plus n minus 2, f of n minus 2, right? So f of 3, we enter there, we are going to call f of 2 because there is n minus 1, f of 2 is going to call f of 1, which in turn is going to call f of 0, then f of minus 1, f of minus 2, up to so on. It will keep on going indefinitely, right? So we need a terminating condition in order to kind of terminate this indefinite loop. In our case, what we can do is, if the index is 0, then we just return 0, and if the index is 1, the Fibonacci index is 1, we know that number 1, Fibonacci number 1 is kept at that place because it is mentioned starting from 0 and 1. So Fibonacci of 0 is 0 and Fibonacci of 1 is 1. So we know these two can act as a terminating condition. So with this terminating condition, if we look at the flow of the execution flow of this function, how would it look like? Let's see. So if we try to solve, let's say, Fibonacci sequence 3. So Fibonacci sequence 3, we are going to enter here. It is going to return, and then it first calls Fibonacci of 2. So Fibonacci of 3 is going to call Fibonacci of 2. And we are not going to go to Fibonacci of 1. So Fibonacci of 3 is equal to return of Fibonacci of 2 plus Fibonacci of 1. But we are not going to call Fibonacci of 1 unless we have completed the processing of Fibonacci of 2. We need a number output from this function, and that is when execution will go here. So if we draw the execution flow, Fibonacci of 3 will go to Fibonacci of 2, which in turn will go to Fibonacci of 1. Just the same thing. Fibonacci of 2 is return Fibonacci of 1, plus Fibonacci of 0, but because, yeah, Fibonacci of 1 plus Fibonacci of 0. So because we cannot go to Fibonacci of 0 because Fibonacci of 1 needs to be processed, so we enter in Fibonacci of 1. Now Fibonacci of 1, we already have a terminating case. For n is equal to 1, we are just going to return 1, so it will not go here, it is just going to return 1. So Fibonacci of 2 is equal to Fibonacci of 1. We have got a return value for Fibonacci of 1 and plus Fibonacci of 0, right? 2, Fibonacci of 2 is 1 plus 0. So after Fibonacci of 1 is processed, we are going to call Fibonacci of 0. Fibonacci of 0 is going to return 0. So Fibonacci of 2 now has both the numbers 1 plus 0. It is going to return 1. So in this way, Fibonacci of 2 has returned 1. Now Fibonacci of 3 is equal to Fibonacci of 2 plus Fibonacci of 1. Fibonacci of 1 was not getting called because Fibonacci of 2 was not processed till now. But guess what? Fibonacci of 2 has been processed now. So Fibonacci of 2 has been processed. This function is going to call Fibonacci of 1 now. And Fibonacci of 1, we know Fibonacci of 1, n is equal to 1, it is a terminating condition, it is going to return 1. In this way, Fibonacci of 3 is equal to just 1 plus 1, that is 2, and 2 is going to be our output. This is how recursion flows. So we have added our terminating condition, we have added our actual recursion. Let's run this. It has passed all the 3 test cases. Let's submit this and see if it properly works and it clears all the test cases. Okay, our solution has been accepted with a good runtime and memory. Cool. So this is recursion, a function calling itself. Thank you.